All right, so let's take a look at graphing this rational function. So just like with everything we've done so far, you want to identify x-intercepts, y-intercepts, and then any asymptotes, and note their multiplicities. So for this one here, I can set my numerator equal to 0. I can factor not only a 3, but I can factor an x out also. So I'm going to be left with, let's see, x minus 4. Oh, there we go. And then set those equal to 0 and solve, and that's where I'm going to end up with my x equals to 0, which has a multiplicity of 1, and 4 also has multiplicity of 1 also. Okay. So once we have those things, those will be my x-intercepts right here. Maybe I'll note those here. X-intercept does not like me writing today. All right. So these things right here, my x-intercepts. And then we want to go ahead and identify the y-intercept. Well, the y-intercept in this case is also going to be 0 because the x-intercept was 0. That's always going to be the case when the x-intercept is 0. From here, though, we need to identify the vertical asymptotes. So as I look over here on the left, or the denominator, I can see that I have, if I were to factor that, I would end up, so for my vertical asymptotes here, I would end up with x minus 3, x plus 1 equals 0. So that means that my vertical asymptotes are x equals to 3 and negative 1. Oh, and negative 1. Both of them have a multiplicity equal to 1, so that applies to both of those. Okay. And so from here, what we're taking a look at is the degree of the top and the bottom, which in this case they're both degree 2. So that means that the horizontal asymptote is going to be the ratio of their leading coefficient. So it's going to be y equals to 3 over 1 or just 3. Now that we have all that information, we can put all that together here in the graph. I'm going to try to do them in different colors here so we can kind of see what's happening. But my vertical asymptotes are a good place to start. So x equals to 3. So that's x equals to 3. We also had x equals to negative 1. Back here. We have a horizontal asymptote at y equals 3. Okay. And now we're going to go ahead and put in our x-intercepts. So we had 0 and 4. 0 and positive 4, so 0, positive 4. The y-intercept's also 0, so we don't have to do that. So as we look at this thing right now, the multiplicity of all the x-intercepts and the vertical asymptotes is 1. So in terms of x-intercepts, the graph is going to pass through. All right, so the one in the middle there, in between the two vertical asymptotes, that's pretty tricky because if you think about it, if it's an odd multiplicity, it has to pass through. So we could have two different scenarios here, one of them being like this, where it's coming in, passing, doing something like that, or you could have it flipping around the other way and doing this. Okay? So we're not really sure which one it's going to be here. So let's investigate the right-hand side, the other branch on the other side of the vertical asymptote at x equals 3. We have a horizontal asymptote up at 3, and so it's unlikely, or it's impossible for the graph to do this, to go through and do this, because if it does that, it's got to come back up to go and be controlled by the horizontal asymptote. So in this case, it doesn't have an x-intercept, so I know it won't do that. So right away, with just using logic here, I know that it's going to look something like this. Remember, the horizontal asymptotes only control end behavior. Okay? So if I know this is true, the multiplicity of all these vertical asymptotes is 1. So that means that the graph will have to go in opposite directions as it approaches from the right-hand side and left-hand side of each of the vertical asymptotes. So the one over here, as we approach 3 from the right, went down to negative infinity. So that means that this one's going to go up to positive infinity. But it has to also hit that x-intercept, and it won't double back on itself because it would not be a function at that point. Okay? Also, I know on the left-hand side, there's no x-intercepts, so the graph has to be confined up here, which also goes along with the idea of the multiplicity of that vertical asymptote, which is that it's odd, so it's going to alternate here. One of the things I should keep an eye out for here, though, also is, in addition to that crossing the horizontal asymptote at the top, I should check to see if there's going to be any intersections with any other additional intersections with that horizontal asymptote. And to get that, I'm going to just do 3. Why is that doing that? 3 equals to f of x. Okay. I don't have time to go through it because I'm running out of my 5 minutes here, but if you set that equal to 0, set that equal to f of x and solve, you're going to end up with just this one x-intercept up, or this one intersection up there. Okay. All right, I hope this helps.